Hello everyone, welcome to our CITM 618 group project presentation. So on today's agenda, we will be discussing 5 objectives. First, we will go into the problem statement. Secondly, we will discuss the methodology. Thirdly, we will go into the dataset description. Next, we will delve into the results of our experiment. And finally, we will go into our conclusion. To begin with, in our project, we conducted an experiment to assess the predictive performance of 4 different classifiers, known as C-tree, J48, KNN, as well as linear classification. Essentially, our goal was to see which is the best classifier in predicting whether a client subscribes to a term deposit based on a variety of client data variables such as age, job, marital status, education, balance, and many more.
Methodology. To achieve our experiment's goal, we're employing 4 classifiers as mentioned in the previous slide. These classifiers play a crucial role in promoting the bank product by analyzing the obtained results and interpreting the findings in line with the experiment's objective. I'll go into details of the first 2 classifiers. Classifier number 1, C-tree. C-tree or conditional inference tree is a decision tree method that uses recursive partitioning for predicting regression. In simpler terms, it is a technique where statistical tests are performed at each point in the decision tree to figure out the relationship in the data. Classifier number 2, J48 tree. Now, the J48 decision tree is a versatile method. It constructs decision trees by breaking down data based on important features. The tree structure consists of root nodes, intermediate nodes, and leaf nodes, each contributing to decisions that lead to various outcomes across different data types. This flexibility makes J48 a valuable tool in our analysis. Now I'll move on to the next classifiers. Classifier number 3 is the linear classification. This method employs a supervised machine learning algorithm using linear combinations of object characteristics. It's like looking at different traits of an object to determine which group it belongs to. The goal is to classify data points into distinct classes. Examples of this would include binary linear classifiers and linear support vector classifiers. The final classifier is the KNN. Now, the KNN, or the K nearest neighbor, is an interesting method. You would imagine picking a number K and considering nearby neighbors with similar features to predict future data points. It's like sorting the variable K to other data points, helping us identify the group of which a data point belongs to. This method adds another layer of understanding by leveraging the characteristics of neighboring data points.
All right, for our next slide, we're going to be describing the dataset in the below picture. The dataset below was generated after running the given CSV file, bank.csv on R. In order to generate the output scripts, they have to be ran using the read.csv method on R. The mean, median, maximum, minimum, first and third quartile are shown on the variables age, balance, day, duration, campaign, P days, and previous. Variables such as housing, default, and loan, and Y only have yes or no options as the optional values. Marital has the options divorced, married, and single. Education has primary, secondary, tertiary, and unknown. Jobs range from blue-collar management, technician, admin, services, retired, other, and unknown. Contacts have cellular, telephone, and unknown. Months have May, July, August, June, November, and April, as well as others. Lastly, outcome has failure, others, success, and unknown. And that is a description of the given data set.
In data science, a careful cleaning process is crucial. We start with a raw data set of 45,211 rows and 17 columns. First, we remove the outcome column to narrow our focus and systematically get rid of the unknowns. The result, a polished data set with 30,907 rows and 16 columns, showcasing precision. But we don't stop there as it transitions to the splitting process. With purposeful planning, 80% of our data goes into the training set and the remaining 20% to the testing set. This allocation primes our models for top-notch performance, blending knowledge and predictive skills. In this data story, cleaning and splitting processes harmonize, creating order from raw information. Our efforts paved the way for insights, making data the bedrock of well-informed decisions.
So based off of the results of the C-tree classifier, the confusion matrix follows as the true positive value is 464, the true negative value is 4,964, the false positive value is 455, and the false negative value is 299. And based off of that, we could determine the accuracy as 87.80%, the error rate as 12.92%, the precision as 60.81%, the recall as 50.49%, and the F1 score of 55.17%.
The J48 classifier's performance is laid out through a confusion matrix. In its predictions, it got no right 431 times, but stumbled 311 times on yes. Conversely, it accurately foresaw no 4,952 times, but mistakenly predicted yes 488 times. Breaking down the numbers, accuracy stands at 87%, indicating the proportion of correct predictions with an error rate of 13%. Precision at 47% reflects the model's accuracy for no, while recall at 58% highlights its ability to catch yes instances. Summing up, the F1 score, a blend of precision and recall, is 52%, giving a holistic view of J48 classifier's performance. In this simplified analysis, every metric contributes to understanding how well the classifier navigates the dataset.
In this slide, we will delve into the results of the linear classification. So on the right, we can see the confusion matrix that was produced. There are 78 true positives in this matrix. There are 31 false positives, 841 false negatives, and 5,232 true negatives. In terms of the performance measures, the accuracy reads at 85.9%, the error rate reads at about 14.11%, the precision reads at 71.6%, the recall reads at about 8.49%, and finally, the F1 score reads at about 15.2%.
For our next slide, we're going to be looking at the results of the KNN classifier. When running the code in R, we generate the confusion matrix with the values below, the true positive being 260, the false positive being 209, the false negative being 659, and the true negative being 5,054. When trying to generate the accuracy rate, the error rate, precision, recall, and F1 score, there are specific formulas we have to follow. For the accuracy, we get 86%. For the error rate of KNN, it's going to be 14%. The precision is going to be 55%, and recall will be 28%, as well as F1 being 37%. And those are the rates for accuracy, error rate, precision, recall, and F1 score. We're using the confusion matrix regarding KNN.
The most accurate classifier was the C-tree classifier with an accuracy of 87.80%. Second place was the J48 classifier with 87.08% accuracy rate. Third place would be the KNN classifier, which had an accuracy of 85.96%. And then last place, the least accurate classifier, was the linear classifier with an accuracy of 84.53%. And based off of that, we can determine the error rate of each classifier. The least accurate classifier was the linear classifier, and the most accurate classifier was the C-tree classifier, which also reflects in the error rates in the bar chart. As we can see that the linear classifier had the highest error rate, and the C-tree had the lowest error rate amongst all the classifiers. The most precise classifier was a linear classifier with a precision rate of 0.6423, and then the least accurate, the least precise classifier was the C-tree classifier at 58.09%, or 0.5809. The C-tree classifier exhibits the highest recall rate among the models, reaching at 0.5049. Following closely is J48 with a recall rate of 0.4690. And at third place is KNN with a recall rate of 0.2829. The lowest recall rate among all the classifiers is the linear classifier, which has a recall rate of 0.0859. As you can see, the difference between the linear classifier and the C-tree classifier, the margin of the recall rates is relatively big. Among all the classifiers, C-tree had the highest F1 score, with J48 coming in a close second amongst all the classifiers. The lowest F1 score was the linear classifier, and the second lowest F1 score was the KNN classifier. All right, so based off our findings, we can determine that the C-tree classifier is the best classifier amongst the classifiers that were looked at. And we can determine this mainly because that the C tree had the second highest precision rate. On top of that, it had the highest F1 score and also had the highest recall and also had the lowest error rate amongst all the classifiers. So based off of all that information, we can determine that the C tree classifier is the best classifier amongst all of them. Thank you guys for watching. Hope you guys enjoyed.